this video, we're going to talk about the graphs of the other three trig functions, cosecant, secant, and cotangent. And you probably noticed my sine and cosine graphs are still here. All right, there's a reason. So cosecant is 1 over sine. So what happens is that when the sine equals 0, we've got badness. Okay, so how I always draw the cosecant graph is I just start with the sine graph. And everywhere it crosses 0, I draw a vertical asymptote. And then at all of the peaks and valleys, if you will, you basically have these kind of parabola-shaped halves floating. So the cosecant graph is just the red graph. So it's this piece, and then these vertical asymptotes in between. So if I kept going, I'd have another floating piece here. And if I kept going, I'd have another floating piece here, and it just keeps repeating. Okay, so this graph, the domain, it's got problems. The domain is basically, you're going to be broken at 0, pi, 2 pi, and all that stuff. So here it's going to be 0 to pi, union pi to 2 pi, union, and you just kind of keep going in that pattern. The range is basically kind of the opposite of the sine graph. So the sine graph was all values between -1 and 1. The range is -infinity to -1, and then I've got an empty spot, and then 1 to infinity. So that's the cosecant graph. All right, the secant. So the secant is the same thing as 1 over cosine. So where cosine equals 0, we've got sadness. Okay. So again, if I come up here and graph vertical asymptotes at all these at pi halves and 3 pi halves, and then if I put these sort of parabola U shapes at the peaks and valleys, then what I'm going to get, as I squish it in, and then there'd be another one over here, and then another floating U, and it just keeps on going. The party never stops. Okay, so here the domain again is basically, it's broken at all of the pi halves, the odd pi halves. There's a cuter way to write it, but we'll just go with it like that. And then the range is -infinity to -1, union 1 to infinity. Boom. Secant. Okay, now let's talk cotangent. All right, I gotta pause it so I can erase the board. All right, so we're gonna talk about the cotangent. Now you'll notice I still have that guy next door, and there's a reason. Cotangent is the same thing as 1 over tangent, but it's also the same thing as cosine over sine. So I have a problem when sine is 0. Life is bad. So that's why I kept my sine graph. So the sine is 0 at 0, pi, 2 pi. So what's going to happen is that this guy's going to have asymptotes at pi, 2 pi, 0, over here at -pi, okay? Now halfway in between all of these, so like at pi halves, it's going to hit the x-axis. All right, and basically it's going to look like a backwards cubit. So where tangent went down and then up, this is going to go like this. All right, so the domain, it is broken at all the even pi's. I should say the whole number pi's. Right, 0, pi, pi, 2 pi. So it's broken at 0, pi, 2 pi, 3 pi, 4 pi, all those guys. Okay. And the range is everything, because it'll go all the way up and all the way down. So there's the cotangent. All right, memorize these graphs. You should know them.